Okay, today we're going to talk about atomic structure and symbols. I'm hoping that a lot of this is a review from your reading and from stuff that we've talked about before, but let's go ahead and get into it. So let's start with atomic structure. The structure of an atom. Again, an atom is the smallest particle of an element that can exist alone. There are two main regions of an atom. We talk about the nucleus. That's the center of the atom. That's where you have protons and neutrons. And we have what we call the electron cloud. That's the area surrounding the nucleus. That's where we're going to find the electrons. So here, this model of an atom, we have the nucleus inside, we have the electrons on the outside. Again, this should be a review from what we talked about before break. Continuing on with the structure of the atom, so we have a proton. Protons have a positive charge, and they have a mass of what we call 1 atomic mass unit. And we find those protons in the nucleus. Just to make sure that we're clear, an AMU, or an atomic mass unit, it's a new mass unit that we've defined. It's the approximate mass of the proton or of a neutron, which brings us to our next subatomic particle, which is a neutron. So the neutron has a neutral charge. It also has a mass of 1 AMU, and we also find it in the nucleus. Our electron has a negative charge, has a very, 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 very small mass. In fact, the mass of an electron is so small that we're essentially going to call it 0. The mass is not 0, but it is so close to 0 that for our purposes here, we're just going to call it 0. I didn't need to know the mass of an electron. The mass of an electron never mattered until my second semester of physics in college. That's finally when I needed to know the mass of an electron. That's finally when it mattered. Up until then, having the electron have a mass of 0 was good enough, and that's what we're going to say in here, that the mass of an electron is 0. And of course, we find that electron in the electron cloud. So again, here we have our protons, our neutrons that are about the same size. Proton has a positive charge, neutron is neutral, and then our electron, which is much, 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 much smaller, and it has a negative charge. When we're talking about counting these particles inside, there's some vocab that we need to go over, make sure that we're all on the same page. Now, if you look behind you at the periodic table, you'll see boxes that look like this. You'll see boxes that look like this. There's a symbol, there are some numbers. We're going to talk very briefly about what those mean. We'll get more in depth in the periodic table in a couple of weeks. So the first thing is the atomic number. Typically it's the number on the top. We abbreviate atomic number, of course, with the letter Z. The atomic number tells us the number of protons in the nucleus of the atom. And the number of protons determines the identity of the element. Every atom of that element has the same number of protons. If you change the number of protons, you change the element. So every atom of a specific element has the same number of protons. For example, carbon atoms have six protons, always and forever. As soon as you change that number of protons, you change the element. The mass number, we abbreviate with the letter A, is the number of protons and neutrons. We're going to add those two together. So it's the total number of particles in the nucleus, the protons and the neutrons. It is always, always, always a whole number because we're counting things. It's always a whole number. Now, if you're looking at the periodic table or you look at the examples that I have up here, you'll notice that these numbers are not a whole number. Well, that's because this is the atomic mass, and the mass number and the atomic mass are not the same thing. Just to confuse you, we have two different terms, mass number and atomic mass, but they don't mean the same thing. So the mass number, what you need to know, the mass number is the number of protons and the number of neutrons. It will always be a whole number. It is not the same as the atomic mass. If you will notice on the periodic table or on the examples here, you will not find the mass number. You cannot look it up on the periodic table. The only way you can find the mass number is by adding the number of protons and the number of neutrons. But we'll talk more about the atomic mass in a little bit. Let's keep going. So another vocab word from your reading is an isotope. Isotopes are atoms of the same element, which means they have the same number of protons, but they have a different number of neutrons. So if you look at this example here of hydrogen, here is hydrogen with one proton, one proton, one proton. The only thing that makes these different from each other is the number of neutrons. This one has 0 neutrons, this one has 1, and this one has 2. So these are isotopes of each other. Same number of protons, different number of neutrons. So that's an isotope. Now, because they have different number of neutrons, they're going to have different mass numbers. Same element, same number of protons, but a different mass number because there's a different number of neutrons. So going back to atomic mass, remember I said we'd get back to it? Well, we're coming back to it. Atomic mass is an average of the naturally occurring isotopes. And that's why it's a decimal. Here for carbon, it's 12.011. And here for boron, it's 10.81 because it's an average of the naturally occurring isotopes. So let's quickly make sure we have mass number and atomic mass separate and we understand the difference between these. So real quick, mass number again is the number of protons and the number of neutrons in one atom. It will always, always, always be a whole number. Atomic mass, on the other hand, is an average of the naturally occurring isotopes of that element. And it very rarely is a whole number because it's an average. So a good way to remember, well, which one do I use, Mr. Ensign? Do I use a mass number or do I use atomic mass? This one, mass number, you cannot find on the periodic table. Atomic mass, you will. So which one do you use? Here's a way for you to remember. If you're talking about a single atom, if the question asks about a single atom or a specific isotope, then you're going to use the mass number. If you're talking about the element as a whole, that's when you use the atomic mass. Again, when you're talking about a single atom, use mass number. If you're talking about the element, if we're talking about a very specific carbon atom, we're going to use mass number. But if we're talking about carbon as a whole, we'll use atomic mass. Okay, let's move on. Now, we've talked about what happens if you change the number of protons, you change the element. We've talked about what happens if you change the number of neutrons. Well, now you have an isotope. Well, what happens when we change the number of electrons? Now, typically, in a neutral atom, the atomic number, again, tells us the number of protons. It's going to be the same as the number of electrons because it's a neutral atom. And all atoms are neutral. We can assume that they're all neutral unless we're told otherwise. So atoms are always neutral unless we're told otherwise. Well, how do we get an atom that's not neutral? Sometimes what happens is that atoms will gain or lose electrons and form what we call ions. Now, atoms will not lose protons. They will not gain protons because that changes the element. That's a totally different thing that we'll talk about in the springtime. For right now, atoms can only gain or lose neutrons. That's what makes them isotopes. Or electrons. That's what makes them ions. Now, excuse me, because electrons have a negative charge, if the atom gains an electron, it will become more negative because it's gaining more negative charge. And the opposite is true. If it loses an electron, it's losing its negativity. It's going to become more positive. So an atom gains electrons, becomes a negative ion. Atom loses electrons, becomes a positive ion. So here's an example. Here we have a positive ion that has 2 protons and 1 electron. And here we have a negative ion with 2 protons and 3 electrons. Now we have special names for these ions. A positive ion is what we call a cation, and a negative ion is what we call an anion. One way you can remember is that cations have cats in the name, and cats have paws, and cations are positive. That's how you can remember. Cations are positive. Okay, well, that's the lesson for today. Hopefully this helped clear up some misconceptions and misunderstandings that you had from the reading and from the simulations you did last week. I noticed as I was going through some of your notes and some of your simulation homework, there were some misconceptions, some misunderstandings. So hopefully this will help clear things up. If you have any questions, let me know. Otherwise, you should be able to fill out your notes now. Yeah, have a great day, guys. I'll see you later. Bye.